Hello, welcome to the project demonstration. In this video, I will describe about an Naive-based classifier that I was developed for the text categorization. This is the main function. In here, I read all the training and testing labels, vocabulary, and dataset. And first, I will create the object, Naive-based classifier object, and I give labels and vocabulary, also the training dataset during the object construction, and because of that I don't need to give the dataset and labels explicitly during the training process, because it's already in the object. And here testing, and these are posterior featured obtaining method, and let's see what is happening. Meanwhile it is calculating. I will walk through the Naive class. Here at the construction, I'll give labels, testing, vocabulary, and training dataset. It read as a numpy array, the panda array, and again vocabulary is given terms, and also I create a list of vocabulary list object. In training dataset, I'll construct the metrics with terms, and also at the end I'll add the category labels for the training label. Also I create a classes set so that I can identify what are the classes in training and testing dataset. And here I can run the class method. In the class method, I'll compute the unique labels in the training label and testing label if there's a difference between training and testing. For example, if class label in testing dataset are higher than training dataset, then I'll give a warning, because it creates some problem when we test the testing dataset. Calculations are finished. I'll show you the result. In training dataset, I'll get the unique class list for my list. Then I'll calculate the I obtain the unique values of each classes. Then I calculate the total classes, that means total documents in that particular class. Then I'll follow the algorithm. Here I take first one class and calculate the prior probability of each class here. Then I'll extract the class 1 document for one document set. Then calculate the term frequency of that particular document. Then calculate the total terms of that document. Then I use this map function to compute the likelihood of each term. This is the term list. Then each item is get taken and add 1, then divided by vocabulary length and the total term frequency. This is the smoothing function, and that's how I calculate the likelihood, and I append it to the class so that I have class and also the conditional probabilities. Here the testing, once it gets testing dataset and testing labels, it compute the posterior probability. Also here I use the map function to compute the all samples posterior probability. This is the class prior probability, and I am calculating the maximum of this posterior probability during the calculation, so that after the computation is finished I know what is the maximum probability class and maximum value. Then I append to the list, then I can print it. And this is where the posterior features are obtained. Here you can see posterior values are calculated, and terms or list I can calculate anything. This is the result, class probability and posterior probability of each term, and I can calculate the predicted class and actual class of each given item, given document, and also the total accuracy can be calculated from this class. Total accuracy is calculated in this method, and thank you for listening.